I'm Dhanashree Rajamani, and today we are going to see about the topic towards reasoning in large language models, a survey. So I have written a Medium article on this topic based on this paper. The link to the article is present here. All right, to begin with, in the recent years, we've been hearing a lot about large language models, and these large language models have made significant progress in natural language processing. And these large language models could exhibit reasoning abilities when these models are sufficiently large, and that is what this article is going to be discussing about. So, in these articles, we also see techniques for improving and eliciting reasoning in these models, and some methods and benchmarks to evaluate the reasoning abilities, and also the current and future state of the field. All right, to begin with, what is reasoning? So, reasoning is a process of thinking in a logical and systematic way, using evidence and past experiences to make a decision or to arrive at a conclusion. So, it involves making inferences, evaluating arguments, and drawing logical conclusions based on available information. So, reasoning is the fundamental aspect of human intelligence, and it plays a very important role in making decisions and critical thinking and problem solving. And this is something which has been uniquely present only to humans. But as seen in the recent years, it has been known that even large language models exhibit reasoning capabilities when they're sufficiently large. So, despite the strong performance of large language models on certain reasoning tasks, it is still unclear whether these LLMs are actually reasoning and to what extent they're capable of reasoning. So, that's what we're going to be seeing about. All right. So, to give a short introduction on the different types of reasonings. So, these are the different types of reasonings that are present. So, detective reasoning is it involves drawing logical conclusions based on truth of the premise. For example, when there is a premise as all mammals have kidneys and premise that all whales are mammals, we can arrive at the conclusion that all whales have kidneys. This is detective reasoning. Inductive reasoning is a conclusion that is drawn based on observations or evidence. For example, when an observation, every time we see a creature with wings, it's a bird. And another observation, we see a creature with wings, then we can conclude that this creature is likely to be a bird. So, this is inductive reasoning. Objective reasoning is conclusions are drawn based on the best explanation for a given set of observation. For example, there is an observation where the car cannot start, and another observation there is a puddle of liquid under the engine. From this, we can conclude that the car has a leak in the radiator. So this is objective reasoning. Analogical reasoning is it involves making comparisons between two or more things in order to arrive at conclusion. Uh, there are also other kinds of reasoning like causal reasoning, which involves identifying and understanding the causes and effects of events. And probabilistic reasoning involves making decisions or arriving at conclusions based on the likelihood of certain outcomes. And there is also formal and informal reasoning. In formal reasoning, it is a systematic and logical process which follows a certain set of rules, principles, and we use mathematics and logic in it. Whereas in informal reasoning, it's based out of intuition, experience, and common sense in order to draw conclusions or solve problems like we do in everyday life. And in this article, we mostly focus on informal deductive reasoning in large language models. So next, we're going to be seeing some techniques that helps in improving or eliciting reasoning in large language models. So recent studies has suggested that the reasoning ability may occur in language models when they are at a certain scale. That is, for example, models with over 100 billion parameters. So since reasoning, we consider that reasoning ability rarely appears in small scale models, and so the focus is on large scale models. So we're going to be seeing on techniques that can improve or elicit reasoning in large scale models. So to begin with, first is fully supervised tuning. So research that is based on fully supervised fine tuning, it involves tasks such as generating rationales that explain model predictions, common sense question answering, and performing reasoning or inference based on implicit or explicit knowledge, and solving problems such as mathematical problems. But this has two major limitations. So this requires fully supervised fine tuning. It requires explicit reasoning data sets, and this can be difficult to create. And another factor is that these models, it may rely on artifacts in the training data in order to predict, rather than actual reasoning for predictions. So these are the two limitations in fully supervised fine tuning. Next, we're going to be seeing about prompting and in context learning, which is a technique for eliciting or improving reasoning in LLMs. So some studies suggest that the lack of exploration in the full capabilities of large language models like GPT-3 is the reason why they seem inadequate for tasks that require multiple steps of reasoning to solve. But these models have demonstrated remarkable few-shot performance for a variety of tasks. All right. Next, we're going to be looking at chain of thought prompting. So, chain of thought prompting is a approach which involves providing a few examples of chain of thoughts, which is nothing but intermediate natural language reasoning steps in order to prompt the large language models. Instead of giving an input and asking for an output, an additional step is involved here, which is chain of thought. So we have an input, a chain of thought, and then an output. So this is an example of how a chain of thought prompting looks like. So when we give an input, says Roger has 5 tennis balls, he buys 2 more cans of tennis balls. So each can has 3 tennis balls. How many balls does he have in a total now? So the chain of thought, we say that Roger started with 5 balls, and then we add 2 cans of 3 tennis balls each. So that is 2 into 3, 6. So 6 plus 5, 11. So this is how chain of thought works. So the answer is output, which is 11. So chain of thought approach engages in reasoning rather than providing answers directly. And this can improve LLM's few shot performance to a great extent. So next we're going to be looking at rational engineering. So rational engineering, it aims to elicit reasoning in large language models through rational refinement. So what we're doing is creating more effective examples of reasoning steps, which is a rational exploration through rational exploration and rational verification, as seen in the figure here. So rational creation and refinement is the first step here, where we create and refine examples that are able to elicit the reasoning in large language models. Next is rational exploration, where LLMs fully explore various ways of reasoning to improve the performance on reasoning tasks. And then is the rational verification, which ensures that the rationales produced by large language models are valid. Next, we're going to be looking at problem decomposition technique. So in which this comes because sometimes the model struggles with complex tasks in chain of thought prompting. So that's why we use problem decomposition, which is a technique where a complex problem is broken down into smaller manageable subproblems, and then solving those subproblems in order to solve the bigger complex problem, which is like divide and conquer basically. So in problem decomposition, we have multiple types like least to most prompting, where the subproblems are divided and solved in a specific order. and then each subproblem is facilitated by answers obtained by previous problems. And then there's dynamic least to most prompting, and then there's successive prompting, in which a complex problem is broken into a simple problem, and then the next subproblem prediction having access to the answers to the previous subproblems. So then we see at hybrid method. So since prompting techniques, it can help in eliciting reasoning in LLMs, but they actually do not improve the reasoning capabilities, as the parameters of the model do not change. So that's why we bring in the hybrid approach, which also improve the reasoning capabilities as well as make better use of these models to solve complex problems. Um, so reasoning enhanced training and prompting shows that fine-tuning or pre-training models on the data sets that include reasoning, or training models on data sets containing mathematical or scientific data that can improve the reasoning capabilities of LLM. So chain of thought data and prompting are critical in improving the reasoning ability of LLMs. So this few shot scratchpad fine tuning, it has led to significant improvements in LLM's ability to generalize to longer problems. Next, we look at bootstrapping and self improving, where the it's the process where LLMs self improve their reasoning abilities instead of fine tuning LLMs on pre built data sets. So, a self taught reasoner star is an example of this kind of model. So LLMs can self-improve reasoning abilities without the need for supervised data, by leveraging the self-consistency of reasoning. Next, we're going to be looking at techniques for measuring reasoning in large language models. So, downstream task performance is nothing but measuring the reasoning abilities of large language models based on their performance on tasks that require reasoning. So, tasks such as arithmetic reasoning. So, the ability of the model to understand and apply mathematical concepts and principles to solve solve problems involving arithmetic operations. Basically, common sense reasoning is using everyday knowledge and understanding to make judgments and predictions about situations. So there are various benchmarks to measure common sense reasoning in large language models, such as strategy QA, ARC, and CSQA. And symbolic reasoning, it involves manipulation of symbols according to formal rules. Um, so there are also other benchmarks to evaluate the reasoning abilities of large language models, such as Big Bench, Scan, Wikitable QA, Feta QA, etc. So more the formal analysis on reasoning, what it suggests is that the existing studies, it focuses on the performance of model, on the accuracy based on the model's accuracy on downstream tasks, rather than actually assessing the reasoning steps of the models. So to determine whether the models are actually able to reason similar to human reasoning, or whether they are achieving it through other means, is a topic where further research is required. So there have been some efforts to develop metrics and benchmarks that enable this kind of formal reasoning in large language models. So these techniques are techniques such as ROSCOE and Folio and so on. So next, we're going to be looking at the findings and implications based on reasoning, whatever we've seen so far, the reasoning in large language models. What are the findings and implications based on this? So first is that reasoning seems to be an emergent ability of large language models. So as we have seen thoroughly before, reasoning seems to be an ability which is only emerging in large language models. So it is important to use these models for the large language models for reasoning problems, rather than utilizing them for smaller problems. And next is chain of thought elicits reasoning. So as we've already seen, chain of thought prompts has improved the performance of large language models on various reasoning tasks, and it has enabled them produce individual valid proof steps. So it has also improved out of distribution robustness of large language models, and this is not observed generally in standard prompting or fully supervised fine tuning paradigms. So but chain of thought prompting, sometimes it still gets wrong steps when there are multiple options available. So that's one limitation there. And the next point is that large language models show human-like content effects on reasoning. So LLM's predictions is based on prior knowledge and abstract reasoning, and the judgments they make are also based on they're impacted by believability of the conclusions. So also, there are cases where large language models do not perform well on reasoning, but these tasks also tend to be complex for human beings as well. So the next is that LLMs are still unskilled at complex reasoning. So, for example, LLMs like GPT-3 and Bloom. So, although they have very impressive reasoning capabilities, they still struggle with some complex reasoning tasks or even simple planning tasks, which involves common sense and which are generally easier for humans. So this shows that the existing benchmarks might be too simple to accurately gauge the true reasoning abilities of large language models. All right, so the next thing we're going to see about is reflection, discussion, and future direction. So, why do we need reasoning? So, reasoning capabilities in large language models enables these models to perform complex tasks which requires advanced thinking, problem solving, decision making. So this makes these models more explainable and interpretable. So that's why reasoning is required. So what are the right applications where reasoning? So it is important to not use these models with extraordinary abilities on simple math solving problems. So it is important to consider more complex, realistic, and meaningful applications such as decision making, legal reasoning, and scientific reasoning. Only then we can understand the true reasoning capabilities of these large language models. So are language models really able to reason? Yes. So here, although there are indications that these large language models are able to reason and they are high performing on tasks and they're able to give reasons step by step. There are also some limitations such as providing inconsistent and incorrect rationales for reasoning. So they also make mistakes sometimes and they are struggling with complex tasks. So it's too early to draw a conclusion here whether the language models are really able to reason, but it is definitely a field where further analysis is required on the training data, on the model architectures, and there is a requirement for better benchmarks in order to measure the reasoning capabilities of LLMs. So it is also in order to improve the reasoning capabilities of LLMs, it's important to utilize the training data, model architecture, and optimization objectives to encourage reasoning, and fine tuning a model with a data set with the chain of thought prompting data or bootstrapping. This also will help improve reasoning capabilities in large language models. Conclusion. Yes. So in this article, we saw about the current state of knowledge on reasoning on large language models, some techniques for improving and eliciting reasoning abilities, the benchmarks and methods for evaluating these reasoning abilities, and findings and implications on large language models with respect to reasoning. So while large language models have made significant progress, it is still unclear whether they're capable of truly reasoning or just rely on memorized patterns and heuristics, and further research is needed in order to understand and improve the capabilities for various applications. Yeah, thank you.